Can you see my presentation?
Yes, we can.
Okay. So, dear participants of the conference, let me introduce my presentation, my report. It aims to the evaluation of the accuracy, stiffness, and stability of the shell structure of mirrorless antenna using simulation modeling. So, the loads on the involved elements of mirror antennas determine the strength and durability, depending on the purpose and method of operation of the device of which the antenna is an integral part. The loads can be of different types and are determined mainly by mechanical, stress, and temperature conditions. The shell elements of the structure of the remote sensing equipment are made in the form of shells of complex shape. When assessing the strength and performance of shell structure, it's necessary to consider various tests. The test of stress strain state stability and bearing capacity in static and dynamic simulation. The theory of shells has been developed with fully and present in various works of scientists. The source of its development is technical specification. The main achievements of the theory are reflected in many works, of which we will highlight manufacturing, production, and design, which were carried out by scientists from Ukraine and brain cultures, as reflected in work. These papers describe the main achievements of the theory of shells, presented the general equation of the theory and methods for solving them, and consider many special problems. A satellite antenna is an antenna used to receive or transmit radio signals between ground stations and artificial Earth satellites. Mirror antennas are the most common class of satellite dishes. They're used in different bands from decimeter waves to Q-band and on different types of stations, from individual TV reception systems to space communication centers. Mirrored antennas are antennas in which the field in the opening is formed as a result of the reflection of an electromagnetic wave from the metal surface of a speech reflector mirror. So you can see the geometrical characteristic of the paraboloid of rotation. The offset antenna is the most common and in individual satellite reception. An offset antenna is an elliptical paraboloid in the cross section of an ellipse. The focus of such a segment is located below the geometric center of the antenna, which eliminates shadowing of the antenna, used area by the irradiator, and its support, which increases its efficiency with the same mirror area as an asymmetric antenna. Typically, offset antenna are used to receive Q-band signals in linear and circular polarization. However, it's also possible to receive a signal in the Q-band as well as combined signals. So you can see the value of the offset antenna. Formation of shells by electric spraying and application of composite material. The formation of mirror antennas consists of several stages. The first stage is the formation of a two-dimensional mesh and the fixing of nodes by electric arc spraying with aluminum. Now we can see electric arc spraying method for mesh material. The mesh blank 3 is placed on the working surface of the punch and its edges are split with a clamp 4. A framed ring 5 is placed on the surface of the mesh blank along the contour of the punch and moved, for example, with elastic clamp 6 in directions that ensure that the blank is primed on the working surface of the punch. As the manufacturer of large size shells, one or more additional mesh blanks with larger meshes and made of wire for larger diameter are applied to the first blank with small meshes. The second stage after spraying on the punch is to obtain a surface with a high temperature and apply a composite material such as polystyrene. So result of wine float modeling. The normal wine float Pascal can be determined in the first approximation by the formula. According to the result of modeling of the flow around the parabolic antenna, which a diameter of 1.5 meter made of a 3 millimeter thick aluminum sheet by an incoming air flow with a speed of 20 meters per second, a value of the normal wine flows of 440 Pascal was obtained, which corresponds to the flow coefficient K 0.9. Wine flows modeling. A solid-state model of a reinforced composite parabolic antenna consisting of the following elements was created: aluminum, spraying, reinforcing mesh, protective plastic, ring of the locking mechanism. Graphical representation of reinforced concrete material. This is a 1.5 meter diameter antenna module consisting of mesh material that has been electrodeposited and a composite layer overlaid on it. To evaluate the stiffness strength characteristic of antenna of solid and reinforced structure, we calculated the stress strain state under the action of point load and gravity. So we can see the safety factor for a 3 millimeter thick aluminum antenna, and we can see the safety factor for a reinforced composite parabolic antenna. The options show results on the estimation of accuracy, stiffness, and stability of shell structure of mirror antennas by means of simulation modeling as a basis for their use in cyber physical boundary system. We can see the deformation of antenna made of a solid sheet of aluminum under wine flow. Scale of deformation display is 2001. Okay, so my conclusion, other conclusion, in the course of the work, the method of manufacturing antenna system and manufacturing reflective filters based on new technological design are considered. The process of formation of shells from mesh material then can be used for the manufacture of axisymmetric and non-axisymmetric reflectors for individual elements of mirror antennas investigated. This is because the formation of this material consists of several stages. The first stage is the formation of the two-dimensional mesh and fixing of the nose by electric spraying with aluminum. The second stage, after sputtering on the punch, is to obtain a surface with a high temperature and apply a composite material such as polystyrene. The calculation allows us to establish, and it's presented graphically that despite the loss of stiffness of the reinforced structure antenna compared to the antenna made of a solid sheet of aluminum, the safety factor of the reinforced structure antenna is 0.8 and remains sufficient, also is significantly less than that of the antenna made of a solid sheet of aluminum. So thank you for attention.